Right, welcome back. We are dealing with the June 2025 paper, which was written in Free State. All right, so question 3 and 4, it's trigonometric questions. Now, 3.1 reads as follows. If sin A minus 3 is equals to 0 and 90 degrees is less than A is less than 270 degrees, determine the following without the use of a calculator and with the aid of a diagram. So the first thing that we need to note are the key things. Here we're given sin 7a minus 3, so we write it here. Sin 7a minus 3 is equal to 0. Now what we do? First thing, we're going to transpose this negative 3, so now it reads 7 sin a is equal to 3. Now, what do we know? We know that this 7 multiplies by sin a, so we divide by 7, we divide by 7. Therefore, now we've got sin a is equals to 3 over 7. Now, the 3, remember, the trig ratio of sin says opposite over hypotenuse. So our numerator is the opposite, our hypotenuse is the denominator. So the first thing, we are done. We now know the value of opposite and hypotenuse. Now, let's go to the second part. Conjunction and introduces 90 degrees is less than A and A is less than 270 degrees. This is what we call the boundary. Now, this boundary is now telling us which quadrants we are supposed to work from, right? So if we come here and we draw, what do we call this? A Cartesian plane. We now have what? This is 90 degrees, this is 0, this is 180, and this is 270, and back here is 360 degrees. So we've been told between 90 to 270, between 90 and 270, we are looking possibly to work with quadrant 2 or quadrant 3. Now 90 degrees is not included, 270 is not included. That's what meant by these inequality signs. Now, how do we determine which quadrant are we going to work on? We come back to this part. Sin A is equals to 3 over 7. So we are dealing with the trig ratio of sin. And the sin, the quadrant that we must work with, is positive, because here 3 over 7 is positive. So between quadrant 2 and quadrant 3, we know that in quadrant number 3, that's where the sin graph is positive. So in other words, now we draw this terminal arm, and then we have our right-angled triangle. So our opposite now, this is angle A, and our opposite happens to be 3, and our hypotenuse happens to be 7. So observe, what we do not have is the adjacent here. And the adjacent, when we look from the point of origin going to the left, it means it's a negative x. So the value of adjacent should be a negative adjacent. We do not have the adjacent, but it's a negative. Right. So now, when they say, let's continue, then they said without the use of a calculator. So the calculations, we shouldn't use a calculator. With the aid of a diagram, this is the diagram they're talking about. Now, we must determine the value of cos A, and it is worth 4 marks. Now, I can't talk about cos here. Why? Because in order for me to have cos A, I must have adjacent over hypotenuse. And like I alluded earlier on, I do not have the value of adjacent. So the first order of business is that I must define the value of adjacent using these two values which have been provided. So in order for me to do that, I'm going to utilize Pythagoras theorem. What does Pythagoras theorem state? It states that hypotenuse squared is equal to opposite squared plus adjacent squared. I know my hypotenuse is 7 squared, my opposite is 3 squared, and my adjacent is what I'm looking for. Now 7 squared gives me 49, which is equals to 3 squared gives me 9, plus adjacent squared. Now what am I going to do? I'm going to transpose the 9. So now I've got 49 minus 9, which is equals to adjacent squared. 49 minus 9 gives me 40. So now I've got 40, which is equals to adjacent squared. Now I'm looking for adjacent, not the squared part. Now, here's the interesting part, what you should never forget. What you should never forget is that you are going to say square root here, plus or minus, which is equals to 40, right? Now, I must also say square root of 40. Why am I putting plus or minus? Because remember, here the adjacent in quadrant number 2, it is negative. So I'm going to use a negative here. So now I say, therefore, adjacent is equals to negative square root of 40. I found the value of adjacent. It's negative square root of 40. But now they wanted me to determine cos. So finding adjacent is step number 1. Step number 2, now I come here and I say cos angle A is equal to, my adjacent is negative square root of 40 all over. What is my hypotenuse? My hypotenuse is 7. And just like that, I get my 4 marks. Right? All right. Now, let's go to question 3.1.2. Question 3.1.2 now requires that we find sin A over tan A. What is sin A over tan A? Now, we say sin, we already know that it is 3 over 7. What is tan? Tan is, now here, let's update here. Let's update our diagram. Our diagram, our adjacent is negative square root of 40. So our tan is opposite over adjacent. So now we are going to say our sin A over our tan A is equal to, the sin A is 3 over 7 divided by our tan A, which is now 3 over square root of negative 40. I use my KCF method, implies that I've got 3 over 7. I change the division sign to a multiplication sign, and then I swap. Now I've got negative square root of 40 all over 3. Why am I keeping on carrying this negative square root of 40? Don't forget, I was told without using a calculator. So how can I round off to certain decimals with my head, right? So now once it's like this, now I say 3 and 3, they cancel, right? So 1 multiplied by negative square root of 40, it's a negative square root of 40 all over 7. So this is the value of sin A over tan A. And just like that, 2 marks, right? So hopefully everything makes sense to the people. Now, let's go to the next question. Question 3.2, it reads as follows. If cos 26 degrees is equals to K, express the following in terms of K. What should we express? Sin 26 degrees and tan 296 degrees. Okay, not a problem. So when you are given cos 26 degrees, what does it imply? It simply implies one thing. It implies that if I'm given 26 degrees here, and this is my 26 degrees, and I'm told that cos 26, so this is my 26 degrees here. My cos, what do I use? I use adjacent over hypotenuse. My adjacent, I've been told this is K. My hypotenuse, it means this is 1. That's what it means when they say K. So, because now, when you now say adjacent over hypotenuse, and you've got K over 1, it's useless for you to keep on writing K over 1, K over 1. We just write what? K, right? So, that's number 1. Number 2, we should determine the value of sin 26. But we've got 2 values here. We've got adjacent and hypotenuse. We do not have what? Opposite. So first order of business is to find opposite. Now, we say hypotenuse squared, which is, we're using our Pythagoras theorem. Hypotenuse squared is equals to opposite squared plus adjacent squared. Hypotenuse, 1 squared, is equals to opposite is what we are looking for, squared. Adjacent, that's K squared. Now, we transpose the K squared. Now we've got 1 squared is equals to 1 minus K squared is equals to opposite squared. We're looking for opposite, so we come here, we say square root of plus or minus, but we're in quadrant number 1 and square root of. So in quadrant number 1, our opposite is positive. So we conclude that therefore our opposite is equal to square root of 1 minus K squared, like that, right? So now that we have found this opposite, what should we do? Oh, no. Sorry about that. I only realized that the camera was something else, was blurry. Okay, now that we know that we've got square root of 1 minus K squared and we should determine the value of sin 26 degrees, what should we do? We come here now, we say sin 26 degrees is equal to what? Our opposite is square root of 1 minus k squared all over our hypotenuse, which is 1, right? Which basically means we've got square root of 1 minus k squared. Even if you leave the answer like that, it's fine. All right. So hopefully it makes sense to the people, right? All right. So let's go to tan 296 degrees. Now, tan 296 degrees, it's a little bit, what do you call it, tricky. All right, let's see. Why am I saying it's tricky? Now, we come, oh yes, tan 296 degrees is equals to, here, which quadrant does tan lie in, right? If we were to draw here our Cartesian plane, 296, this is 270 here. So this is where you find tan here, 296. You're in quadrant number 4. And if we use our cast diagram, we say, in this fourth quadrant, our tan is negative, right? Now, in this quadrant, you say 360 minus theta, right? But if I say 360 minus 296, what do I get? Oh, sorry, I'm supposed to say 2, then I've got 15, then I've got 6, right? 64 degrees. But we were not given 64 degrees here. They want us to use 26 degrees. So this trig ratio cannot work of 360 minus. What can work? Because we need to utilize 26 degrees. What can work is now the fact that tan 270, remember we are here, and you can't get a number here only by saying 360 minus. You can also say 270 plus. So we're going to say 270 degrees plus 26 degrees. It will give me 296 degrees, right? But the moment I use this tan is equals to 270 plus 26, I must now say that, remember we must use our reference angle should be a, what do you call this thing? Our reference angle should be an acute angle. So here, in other words, we're now having tan 26 degrees, right? But we are now going to use what? A negative cot, the opposite of the inverse of this. Negative cot 26 degrees. Now, if we're going to use, remember, why am I saying negative? Because it's negative in this quadrant, right? Now, when I say negative cot 26 degrees, what do I get? Remember, we've got 1 over tan 26 degrees. 1 over tan is equals to cot, right? So now, when I've got this 1 over tan 26 degrees, right? Now, what do we do? I can't keep on using this because I was instructed not to use a calculator. So what do? I go to the other one, the other inverse of tan, which is cot, but whereby we are dealing with sides. Remember, when you have got your tan theta, what do you say? You say sin theta over cos theta. Now, when you go for cot using the sides, cot theta therefore becomes what? It becomes cos theta over sin theta. So we're not going to use 1 over tan 26 degrees. We're going to use cos theta over sin theta. What is our cos theta? Let's remember the values that we were given. The values which were given were what? We had here, we had k, we had 1, we had square root of 1 minus k squared here. So if we go for cos theta, remember what is cos theta? K over 1. So now we're saying k over 1 divided by, we go for sine theta. What did we find under sine theta? It was opposite over, opposite over hypotenuse, which is square root of 1 minus k squared over 1. But we must not forget one thing which is happening here. What's happening? In this quadrant, in this fourth quadrant, remember what happens? If we come here and we say that we've got 26 degrees, our cos is positive, so this part is positive, but our sin in this fourth quadrant is negative. So in other words, here where we said sin, it should be a negative. So now, we are going to write k over 1 We change the sign, the division side, it becomes a multiplication. Now we flip, it becomes negative 1 over square root of what? 1 minus k squared. There. Now, what are we going to do? Now we're going to say that k multiplied by a negative 1, it gives us a negative k, all over 1 multiplied by square root, it gives us square root of 1 minus k squared. So this is the final answer. For tan 296, it is equals to negative k over square root of 1 minus k squared. This is the answer that we get, right? Hopefully it's understandable. Let's continue. Now, we are done with question 3. We must go to question 4. Question 4, we are now dealing with what? We are now dealing with simplify without using a calculator. What we are provided that we have got tan 330 degrees. So we say tan 330 degrees minus sin 120 degrees multiplied by cos 240 degrees. So here we must utilize our reduction formulae. So our reduction formulae, what does it state? If I come to tan 330 degrees, where do I find 330 degrees? I find 330 degrees in this fourth quadrant. So, what do I use here? Remember, cast. In the fourth quadrant, cos is what? Positive. But anyway, we use 360 degrees minus theta here. So here I'm now going to write tan, open bracket. For me to get 330, I say 360 degrees minus 30 degrees, right? Minus, if I come to sin 120, in which quadrant do I find sin 120? I find it in quadrant number 2 here. And sin is positive here. Which reduction formula do we use here? We use 180 degrees minus theta. So now I'm going to say that I have got sin, open bracket, 180 degrees minus, for me to get 120, I said minus 60 degrees. Then we've got cos 240, cos 240, which is cos, open bracket. Where is 240? 240 is found here in quadrant number 3. And what is the reduction formula? It says 180 degrees plus theta. So I come here and I say 180 degrees plus 60 degrees will give me 240. So this is the first step. The question is how many marks? 5 marks. So you get 1 mark just for doing this. Then on the next step, we now say we are now going to be using the reference angle, which is these acute angles. Now I say I've got tan 30 degrees and then minus sin 60 degrees multiplied by cos 60 degrees. Now, what should I do? This is the point whereby now I'm now going to use my what? I'm now going to use my special angles. Remember, when it comes to special angles, the triangles of special angles, there's one thing which happens here we've got 2 different types of special angles, which is a scalene and an isosceles triangle. So here we need an isosceles. Why am I saying we need isosceles? Not isosceles, man, scalene. The scalene one has got 30 and 60 degrees. So let me draw the scalene one on my triangles of special angles. Here, this is 30 degrees. This is 60 degrees. This is 90 degrees. Now, what do I know? I've got 3 unequal angles, which means I've got 3 unequal sides. So here, opposite, I've got 1, hypotenuse is 2, and there I've got square root of 3. Now, if I'm given, they said tan 30 degrees, I look at what? This is 30. And tan says opposite over adjacent. Opposite is 1. My adjacent is square root of 3, right? So I'm updating on the other side that tan 30 degrees is equals to 1 over square root of 3 minus my sin 60. What is my sin 60? My sin, this is my 60 degrees. Opposite is equals to square root of 3. Sin 60 degrees is equals to square root of 3. My hypotenuse is 2 over 2. So I update on this other side, square root of 3 over 2 multiplied by cos 60. Cos is adjacent over hypotenuse, which is 1 over 2. So I say multiplied by 1 over 2. Now let's come back to the other part of the board here. This is what I've written, right? 1 over square root of 3 minus square root of 3 over 2 multiplied by 1 over 2. But I mustn't forget, in which quadrant did I find this? I was in quadrant number what? I was in quadrant number 4. In quadrant number 4, is my turn positive? No, it's negative. So here I've got what? I've got negative 1 over square root of 3 minus, in the second quadrant, my sin is positive, which is fine. And in the third quadrant, my cos 60 degrees in the third quadrant, it's what? It's negative. So I've got a negative 1 over 2 here. So now what do I do moving forward? I'm now going to start here. I'm now using the BODMAS rule. Why? There is multiplication. So I rewrite negative 1 over square root of 3 minus, now I say positive multiplied by this negative, it gives me a negative. So I put a negative, square root of 3 multiplied by 1, it's square root of 3. And 2 multiplied by 2, it gives me 4. But now I put it inside the bracket. So I must say negative multiplied by negative, which gives me a positive square root of 3 over 4. And here I've got a negative 1 over square root of 3. Right? Now, if I'm under fractions, what do I know? I need to have identical denominators, and I do not have that. So I must define the lowest common denominator. Here I've got square root of 3. I don't have the denominator of 4. So I come this side, I multiply by 4 over 4. And this side I don't have square root of 3. So I multiply by square root of 3 over square root of 3, which is equals to, now I say positive multiplied by negative, it gives me a negative. 4 by 1 is equal to 4 over 4 multiplied by square root of 3, it gives me 4 root of 3. And then I've got a plus. Square root of 3 multiplied by square root of 3, it gives me square root of 9. What is square root of 9? Is 3. So I write my 3 here. Over 4 multiplied by square root of 3, it gives me 4 square root of 3. So now what do I have? I've got identical denominators. And once I've got identical denominators like this, it means I'm going to write a single denominator, 4 square root of 3. And then now I've got negative 4 plus 3. Negative 4 plus 3 is equals to negative 1. So my answer is negative 1 over 4 square root of 3. This is my final answer. Right? Okay. Or if you want, you can also use a conjugate here so that you can remove this square root of 3. Okay. But let's go to question 4 point what? Question 4.2. We're still using our reduction formulae. Now, this time around, what are we given? We are given the question which reads as follows. We've got sine 180 degrees minus theta. So sine 180 degrees minus theta multiplied by cos open bracket negative theta cos 25 degrees, and this is all over sine open bracket 90 degrees plus theta, and this is sine 425. Okay, now in which quadrant do I find 180 minus theta? It's quadrant number 2. Is sine positive in quadrant number 2? The answer is yes. So I write my sine theta here. And then I've got cos minus negative theta. So I now write it multiplied by negative cos theta here. Then I've got cos 25 degrees. I write cos 25 degrees. All right. Then this is all over. I'm given sine 90 plus theta. Now, what happens? We've got what we call co-ratios, right? What we call co-ratios. Let me just come to this side and draw a mini. What happens with co-ratios? If I'm in quadrant number 1, I've got sine, open bracket, 90 minus theta. Whenever I see sine 90 minus theta, I turn it to a cos theta. If I've got cos, open bracket, 90 degrees minus theta, I turn this into a sine theta. If I come to quadrant number 2, where I have got sine 90 degrees plus theta, I turn this to a cos theta. If I'm given cos, open bracket, 90 degrees plus theta, then I turn this to a negative sine theta. Why do I turn it to a negative sine theta? Because in this quadrant number 2, cos is not positive, it is negative, right? So if here on my question here, I'm having sine 90 plus theta, it means I must turn it to a cos theta. So that's what I'm going to do. They are called co-ratios or co-functions. So now I turn it into a cos theta multiplied by sin 425. Now, what happens with sin 425? It is way above the revolution. What do I mean by that? Remember to say that you have got a what? It was called a unit circle. You have got a unit circle. Your Cartesian plane is found inside a unit circle. And a circle has got what? 360 degrees. Hence, we call it a revolution. So now the 425, it means to say that we have gone for a one revolution. Now we are going for the second time. So we do not work with these numbers when they are big like that. Remember, we always need to work with acute angles, and acute angles are angles which are less than 90 degrees. So what do? We now then come and say sin, open bracket, 425, we reduce it by 360 degrees, right? We reduce it, and we need to figure out in which quadrant does this sin 425 lie through reducing. Now, if we go to the next step, we now say we rewrite sin theta. So we've got sin theta here, right? Now, remember, these are all multiplying. This is not a minus, this is a negative. Cos theta is coming from cos, open bracket, negative theta, which is a negative angle. And here I've got cos theta on the denominator. So I'm allowed to cancel these two. Now I'm left with negative 1 there. And I've got cos 25. So now, what happens? Now I'm going to say negative multiplied by this. So this sine theta, I'm going to call it a negative sine theta, I say multiplied by cos 25 degrees all over. Now when I say 425 degrees minus what? Minus 360. 12 minus 6 is 6. So I've got what? Sin 65 degrees. Sin 65 degrees. Now, remember, there is something that you were taught in grade 8 about complementary angles. Complementary angles are angles which add up to what? To 90 degrees. So if I'm at 65 degrees, how many degrees am I left with to get to 90 degrees? If I say 65 plus 25, 5 plus 5, that's 10. 6 plus 2, 8 plus 1, 9. 90 degrees. So in other words, this sin 65 degrees, if you go and you press your calculator, sin 65 degrees, the reason which I told you about co-ratios here, if you press sin 65 degrees, it is equal to cos 25 degrees. So I've got a choice here. This sin 65 degrees, check how I will deal with it on the next side. Now, I'm going to say that I've got negative sin theta multiplied by cos 25 degrees. I'm now going to change this sin 65 and I'm going to call it cos 25 degrees, right? So these two are identical. So now I say cos cancels out cos. So I'm left with a negative sin theta. That's my final answer, just like that. I've used my co-ratios, right? Okay, and I to find this. Now, let me go to the next one, 4.3. So, okay, before I proceed, it's very important for a person to understand their theory, because if you do not understand your trig theory, then you will have problems. Whether you are on functions or you are dealing with trig ratios or trig equations, if your theory is not strong, then you will have problems. All right. So on this particular question, what are we given? We are given that we must prove the following identity. sin theta minus tan theta multiplied by cos squared theta all over cos theta minus 1 plus sin squared theta is equals to tan theta. So this is an identity. So when you've got an identity like this one, what do you need? The left hand side has got a lot more things to work on than tan theta, because tan theta just is sin theta over cos theta. So what are we going to do? All right, the first thing which I'm going to do, I'm going to rewrite sin theta. So I rewrite sin theta here minus this tan theta. I'm going to convert it to become sin theta over cos theta multiplied by, now I've got cos squared theta here, cos squared theta all over 1 is all over. So here on the left hand side, I must say left hand side is equal to, then here I've got cos theta, so I say cos theta here minus 1, right? Then I've got sin squared theta here. Now the sin squared theta, I want you to remember about Pythagorean identities. What do Pythagorean identities say? If I've got sin squared theta plus cos squared theta, it is equal to 1. So when I've got this sin squared, I can say sin squared theta is equal to 1. I transpose the cos squared, it becomes a negative cos squared what? Theta there. So I'm going to convert this sin squared theta to become a 1 minus cos squared theta. So let me do that. So now I've got plus 1 minus cos squared theta here. All right, hopefully people remember their Pythagorean identities. Now what am I going to do on the next stage here? Before I go and write sin theta, now I'm saying I've got cos theta and cos squared theta, and there's a common factor. So this cos theta cancels 1 out of the 2 cos squared thetas, so which means that we are left with 1 cos theta here on the numerator. So now we've got sin theta minus sin theta multiplied by cos theta, like that, right? All over. Now observe here, now I've got minus 1 and positive 1 here. So these two, they cancel out, right? Please do not cancel out like that in an examination. You are not teachers. You are not allowed to do that. I can do that. So on the denominator now we've got cos theta minus cos squared theta. At this stage I'm now going to factorize. Why? Because I've got a minus sign and a minus sign. Remember, I can't cancel this cos theta to that cos theta because of this minus sign and minus sign. Even if there was a positive here, if there's a positive or a minus, I can't cancel out. So when I'm going to factorize, remember I have to factor out what is common. On my numerator, sin theta, that is the common one. So I'm going to write that I'm factoring out sin theta. I open the bracket. For me to have this sin theta, I say sin theta multiplied by 1. And on the second term, I've got a positive outside, there's a negative here, which means there's a negative. And then it was sin theta multiplied by cos theta for us to have sin theta cos theta. So I write cos theta here. I close the bracket. I come here, I've got cos theta minus cos squared theta. So I'm going to factorize. I factor out cos theta. I open the bracket. For me to have this cos theta multiplied by 1. And then there is a positive outside, and here there's a negative, so I place a negative. And I've got 2 cos squared thetas here, but I've got cos to the power 1 outside. For it to be cos to the power 2, I multiplied with another cos theta, right? So observe now, these are multiplying. The numerator is multiplying, the denominator is multiplying, and I've got common factors here. So now these two, they cancel. I'm left with sin theta over cos theta. And remember, sin theta over cos theta is equal to what? It is equal to tan theta. So now, because I found this tan theta, I now say is equal to, remember I said left hand side is equal. It is equal to what? It is equal to the right hand side. I've proved it, right? So it's a combination of understanding your Pythagorean identities, right? Okay, hopefully everybody understood. Now let's go to the last question, right? The last question is about general solutions. general solutions. And with these general solutions, what are we going to do? Now we're given 6 cos squared x minus 7 cos x minus 3 is equals to 0. What we need to do here, we need to factorize. That is the first step. But if I'm to factorize using this, then I will have problems, right? So what do? Let me use what we call the K method. K method will make things easier. What do I mean by that? Now, where there is cos, I say, let cos x equal to k. So where there is cos, I say k. So here I've got 6, but it's cos squared x, which means that I've got 6k squared minus 7k minus 3 is equal to 0. Now I've got 6 here, which means that I open the bracket of 2 and 3, I say is equal to 0. I've got k squared, which means here I've got k. Let me put my 3 this side rather, and my smaller 2 that side. So I've got k and k. I come here and I check. What do I have? I've got a negative sign, which means one of these boxes must have a negative, another one must have a positive. Okay, so if I say 3 multiplied by 2, I get my 6. And then here I'm going to put a positive here. Let me put my positive there. Let me put my negative there. Now, which number will give me negative 3? It's 1 and I've got 1 and negative 3, or I've got negative 1 and positive 3. So if I put if here I put a negative 1 here, I'll say 3 by negative 1, it will give me a negative 3. And if I put a 3 here, 3 by 2 will give me what? 3 by 2 will give me 6. And 6 minus 3 won't give me 7. So I can't do that. All right. If I put... Okay, so let me try and put a negative 3 here. If I now say positive times negative, it gives me a negative. If I say 3 and 3, it will give me a 9k. If I put a positive 1 here, 1 times 2, it will give me a positive 2k. And negative 9 and 2, it will give me a negative 7, which is what I have here. Okay, so it's fine. So, all right, and now I've got 3k plus 1 and 2k minus 3 is equal to 0. So now, I now say 3k plus 1 is equal to 0, or 2k minus 3 is equal to 0. Now, when I proceed now, I'm going to say that 3k is equal to negative 1, or 2k is equal to 3. Now, remember, we were not asked to solve in terms of k. We converted it to k to make it easier for us to factorize. So now I'm going to say 3 cos x is equal to negative 1, or my 2 cos x is equal to 3. I now divide by 3 on both sides, right? And then here I divide by 2 and I divide by 2. 3 into 3 is 1. So here I've got cos x is equal to negative 1 over 3. Or 2 into 2, that's 1. I've got cos x, which is equals to 3 over 2. Before I even proceed with this one, I write that this is invalid. Why am I writing that this is invalid? Remember what you were taught in grade 10, and I said it earlier on in this lesson. I said your Cartesian plane is found inside a circle. And once it's found inside this circle, from your point of origin to the circumference, this radius, it is 1. From here to there, it is also 1. From here to there, negative 1. From here to there, it's negative 1. So your Cartesian plane, the maximum value which you have, it's a positive 1. Your minimum value is a negative 1. And now if you come to 3 over 2, 3 over 2 is equals to 1.5, which is beyond the Cartesian plane. So this is not going to be a solution, right? Okay, hopefully everybody understands the elucidation. All right. Now, what are we going to do? Now we're going to continue and say that, okay, now we've got cos x is equals to negative a third. Now we say x is equal to, we transpose this cos, it becomes inverse cos, open bracket, negative 1 over 3. So we must go to the calculator and find this one, right? All right. Let me just pause the video to fetch my calculator. All right. So here, if we come to the calculator, we now say shift cos negative 1 over 3. We close the bracket. It is equals to 109.47, right? 109.47, or no, let's not put this negative. We must punch it as inverse cos 1 over 3 here and get 70.52. This is our answer. So what are we going to do? Let's go back to the Cartesian plane. We are now here. Now, what's going to happen? We have got this particular Cartesian plane, and when we're having this particular Cartesian plane, what's happening? What's happening is now the fact that where do we find a negative cos, right? We find a negative cos in quadrant number 2 and quadrant number 3. So we must calculate this, this general solution for quadrant number 2 and quadrant number 3. That's where the solutions lie. So remember, in quadrant number 2, it says 180 minus theta. So now we are saying x is equal to, we now write this 70.5, 70.52, I say ellipsis degrees plus k. Oh, no, I made a mistake. Sorry. I'm saying one thing, I'm writing the other thing. The mistake I made is that I didn't consider the reduction formulae. I'm supposed to write 180 degrees minus 70.52 ellipsis degrees plus k, right, multiplied by 360, and they are elements of integers. So I come to my calculator now. I say 180 minus the 70 something, it gives me 109.47, right? So I say, therefore, my x is equals to 109, now I'm going to round it off to 2 decimal places. Why am I rounding it off? This is the final answer. I'm using the instruction from the first page, which says I must round off to 2 decimal places. I found the answer for quadrant number 2, whereby the reduction formula says 180 minus theta. Now I say, or, now I must find the solution for what? I must find the solution for quadrant number 3. In quadrant number 3, what does the reduction formula say? In quadrant number 3, it says 180 plus. So I come and I say x is equals to 180 degrees plus the 70.52 ellipsis plus k multiplied by 360, being elements of integers. So now I say 180 plus 70 gives me 250. So x is equals to 250 degrees, 53, right? 53 degrees. Then I say plus k multiplied by 360, and they are elements of integers. And once I've done this, I'm done. Then I get my full 6 marks. So hopefully everybody understood what I did here. If you found this video to be helpful, please do consider subscribing, share with others, comment and like. Till we meet next time, cheers.